Chapter 9 goes deeper into what we started in Chapter 8. It's all about the molecular geometry and all about different theories of bonding. This is as far as 1210 is going to take you. I want you to focus on the pictures and on the figures. It will help you understand what we're trying to explain. There's going to be electron domains with electron domain geometry and molecular geometry. We're going to have a section on hybrid orbitals, and we're going to have a section on atomic orbitals and molecular orbitals. A lot of this might be very new to you, so hang on. As usual, here are the questions that have been signed for homework. If you do them, please ask us questions. I don't think I've ever taught this where even my top students did not have some questions about what we're discussing. So this section is very simple. It is called molecular shapes. When we did a Lewis structure, like let's say for methane, what we did is we showed how all the different hydrogen atoms were bounded to carbon. Missing a shape. Some of you have heard of flat Stanley. Well, as we've drawn it here, this is a two-dimensional molecule. What is missing is, okay, I can say it's two-dimensional, I can say it's flat, but molecules actually adopt 3D shapes. As you get deeper into your studies, you'll learn how important all the shapes are for things like DNA and enzymes and viruses. You'll just learn all of that, and this is really the starting point. So I already drew methane, CH4, and for whatever reason, your textbook did not do methane. What they said, again, is as I kind of said, if I draw it flat, the Lewis structure is 2D, and it looks very planar with 90-degree angles between the hydrogen, carbon, hydrogen. All the bonds look equal. But when they ran experiments by taking the crystal structure, what they found were the bond angles were 109.5. Always reminds me of a radio station. And so this is called tetrahedral. And that's what this section is to teach you about, the different shapes that molecules can adopt. So when we have this one on the bottom, the CCl4, like I wish it was just methane, but it is not, know that we can say CX4, where X can be hydrogen, chlorine, fluorine, bromine, or iodine. So we're going to begin by saying that molecules are composed of only two kinds of elements. That should be a capital B. We will say ABN. If I have an AB2, it will be linear. If I have an AB3, it'll be trigonal planar. If I have a tetrahedral, it'll be AB4. If I have a trigonal bipyramidal, it'll be AB5. And if I have an octahedral, it will be AB6. And that's what this section is trying to teach you. We will have only two kinds of elements, primarily in chemistry 1210, and those are what their formulas look like. And here we have a picture. Note the shapes, the same words I used before: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. The other thing I want you to note are the angles. Linear is always 180, trigonal planar is always 120, tetrahedral is 109.5. When I have a trigonal bipyramidal, 3 of the atoms lie in the XY plane, and 2 of the atoms lie on the z-axis. As you're sitting here, there is no chemistry here, is there? There is molecular geometry, and it really is based on the XYZ axis. When I look at the AB6, there is an XY plane where 4 of the atoms lie, and then 2 of them lie on the z-axis. The only difference is with the octahedral, we're at 90. 4 divided by 360 is 90. With the trigonal bipyramidal, we're at 120. 360 divided by 3 is 120. So what is this picture with the corner? This is in the Washington, D.C. It's in the National Portrait Gallery. I believe it's on the 4th floor. I actually saw this, but a student who was in our class, after visiting the gallery, sent it to me, and you can see it is art, and I do love art, and that is an octahedron. So what's going to happen in this chapter? Well, I want to make sure you know what we mean by AB. If I say AB2. You picture a B with an A with a B. Here we have carbon with oxygen and oxygen. Here we have sulfur with oxygen and oxygen. But look how one says linear and look how one says bent. That's what this chapter is going to teach you. Same if we have AB3. Now this one gets a little bit trickier. I'm not even going to draw it out. But as you can see, sulfur, oxygen, 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 just like we had in the beginning. But all of a sudden, it takes a different shape, and that's because there's a lone pair of electrons, as well as here, there are two lone pairs of electrons. And we're going to teach that in this course. When all of them are the same, it's trigonal planar. When we have some lone pairs, one of them, it's trigonal pyramidal. And when we have two lone pairs, it is T-shaped. Students tend to struggle with this. I'm not going to lie. The main ones in this first row column, they are very easy, but we're going to teach you how the other ones come about.